All right, you guys. So here we are. It's time to discuss properties of logarithms to a further degree. So at this point, we've already discussed, let me skip past the warm up here. We've talked about properties for things similar to logarithms, the inverse. We talked about properties for exponents. So this hopefully is not super surprising to see rules like this. And I'd maybe pause, refresh yourself on rules like this, and think about how it would kind of make sense that logarithms, which are exponents, would also have properties that operate in similar, slightly different, but similar manners. Okay? You guys have already learned one of the big ones, which is the inverse property of logs, that log base b of b to the x is just x, and that b to the power of log base b to the x is just x, that these things undo each other. That's super, super important. And then we got these three. The product property, which says that if you have the log base b of something, and it listed as m times n, but you're typically going to see it more as something like 30, and you know that you can break that up into 6 times 5. And so it would be the log base b of 6 plus the log base b of 5. The quotient property, so when you see a fraction, you're immediately thinking, well, I can split that up into subtraction. And then the power property, which says that the log base b of m to the power of n is really, you can bump that n all the way out to the outside as n times the logarithm. That's something we discussed in yesterday's class when we were talking about how logs and exponents function as inverses, and we were writing the inverse of an exponential function where the variable was in the power there. And we wound up getting that you could have written the inverse like this, and you could have written the inverse like what's here on the left. So I want to show you here. So here's some examples of how we'll break this up. And you can see my note here that, hey, the idea that the log base b of b to the x equals x comes from this idea of the power property, right? Like that we know the log base b of b is 1, like whatever it is just 1. So when I see the log base 2 of 2 to the third, I know it's 3 because I can move the 3 to the front. Now it's 3 times the log base 2 of 2, and the log base 2 of 2 is just 1. So I have 3 times 1, which is 3. So that's where sort of we get that property. You're probably thinking to yourself, what's going on here? You said that we'd be working on learning how do I actually solve log base 2 of 3 or log base 2 of 5. We are getting there. I promise you, we are getting there. But for now, I'm basically going to give you like a key. So I'll basically tell you, look, we haven't learned change of base yet. So can you do log base 4 of 3 on your calculator? No, you can't. You can't because, well, our calculators only have log base 10 and log base e, the common log and the natural log. So we can't at this point figure out log base 4 of 3, but I can provide you with an estimation of what they are, and then you can see something like the log base 4 of 3 over 7 and go, oh, well, that's log base 4 of 3 minus log base 4 of 7, and Mr. Card gave me those in the key, so I can just do 0.792 minus 1.404. So I would ask that you try, like if this is my key, why don't you look at these, think of the rules, and then can you try and piece it together? Hit pause now, try it, and I'm just going to immediately skip to these slides where I show you what we did. So 5 over 8, I go, well, that's log base 6 of 5 minus log base 6 of 8. So 0.898 minus 1.161. Here, 40 I recognize as, well, that's 5 times 8. So it's log base 6 of 5 plus log base 6 of 8. So I'll add them together. And then we have the log base 6 of 64. And I go, well, that's 8 squared. So I'm going to bump that 2 out as a multiplier in the front. 2 times the log base 6 of 8. And that's 2.322. And then here, log base 6 of 125. Well, that's the log base 6 of 5 cubed. So I'm bumped that 3 out as a multiplier. 3 times 0.898. And the other types of problems that it'll give you, which they're not as exciting because we're not doing real evaluations. It's more practicing with the properties. So it's good for having a firm grasp on the properties, but it doesn't really have any relevance to like problem solving. And that's expanding. So taking something that's compressed and saying, can you recognize that 5x cubed over y, I can split that up into subtraction. And then, the 5 times x cubed, I can split that up into addition. And the x cubed, I can bump the 3 outside and sort of expand it. And then the inverse, or like the opposite, going the other way would also be true, which is, can you compress something like this? So this would be another one where I'd say, if you're at home, you're taking the notes, pause the video, try and see if you can use the rules that I mentioned earlier to compress this. You should do something like this, where you go, well, the first thing I could probably do is take the 3 and push it up here, right? And then from there, take the 9 and the 8, multiply those because they're being added together. So now I have 72 minus log base 10 of 3. Okay, well, 72 over 3 is 24. So I can compress this all the way to just being the log of 24. Which that I could do on my calculator, right? If I just see regular log, no base, that implies base 10. That's the common log. So I could figure that one out on my calculator. I know it might be frustrating to be this far, and I promise you we're getting closer. It's the very next thing we learn is I'm giving you this as a key. We will learn. The next thing we will learn will be the change of base formula so that you can do that on your own. And at that point, we can start solving word problems. At that point, we're essentially done, and we've mastered the art of the logarithm. So I hope this video is helpful, and we'll have another one soon for change of base.